Hi, I'm Tom Homi from Dell EMC. In this demonstration, I'm going to show you the integration between Dell EMC PowerStore and VMware Virtual Volumes. VMware Virtual Volumes was introduced in vSphere version 6.0. This is a storage technology that provides policy-based granular storage configuration and control of VMware virtual machines through API-based interaction with the underlying storage. VVOL benefits include virtual disk granularity, automatic provisioning, array-level VM visibility, storage policy-based management, and more. By navigating to the Storage Containers tab, you can find the default storage container, which is created during the PowerStore installation. Unlike traditional LAN-based vSphere storage, the VVOLs functionality does not require pre-configured volumes on the array side. Instead, VVOLs use a storage container, which is a pool of raw storage capacity or storage capabilities that a storage system can provide to VVOLs. In addition to the default storage container, PowerStore supports additional storage containers creation. You can create quota on those storage containers and limit their maximum capacity for different tenants, for example. For the purpose of this demo, I'm creating a new storage container with a quota of 20 terabytes. A virtual volume storage provider, also called a VASA provider, is a software component that acts as a storage awareness service for vSphere. The provider mediates out-of-band communication between vCenter server and the ESXi host on one side and the storage system on the other side. In the vSphere client inventory pane, host and cluster view, select the target vCenter, then select the Configuration tab and click Storage Providers in the menu. Now, click the plus icon to launch a new storage provider wizard. Under Name, we can enter a friendly name of the VASA provider. The URL is the URL of the VASA provider of our storage array. Credentials is the user and password for our storage array. Now that VASA is registered, we can connect our vCenter server to PowerStore array. From the PowerStore UI, we can navigate to the vCenter Connection tab and then click Connect. Here, we specify the vCenter IP address, username, and password, and then click Connect. This feature provides VMware Virtual Machine awareness from the PowerStore UI. Now, we can move to the next step and mount the VVOL datastore. To mount a VVOL datastore, we right-click on the target host or cluster, select Storage from the drop-down menu, and select New Datastore from the secondary drop-down to launch a new datastore wizard. Now, we click on the VVOL radio button and then click Next. We enter a friendly name for the datastore and select the VVOL container as the backing storage container list. We select the host on which to mount the VVOL datastore and then we click Finish. To mount the VVOL datastore to additional host, we right-click its row in the vCenter client and then select Mount Datastore to Additional Host from the drop-down menu to launch the Mount Datastore Additional Host wizard. Then we select the host to which to mount the VVOL datastore by clicking the checkbox and then click Finish. In addition to this manual creation, the VSI plugin allows us to create a VVOL datastore directly from the vSphere client. To create a VVOL datastore using the VSI plugin, right-click on the target host or cluster, select the Dell EMC VSI plugin from the drop-down menu, then select New Datastore from the secondary drop-down to launch the New Datastore wizard. Here, we select VVOL block, provide a friendly name, and select our PowerStore array. Here, we can also set capacity quota on that VVOL datastore. Now, we can click Finish to complete the task. By navigating to the PowerStore UI, we can see that a new VVOL has been created. Although storage systems manage all aspects of VVOLs, E6i hosts have no direct access to VVOL on the storage side. Instead, E6i hosts use a logical I/O proxy called PE, Protocol Endpoint, to communicate with VVOLs and virtual disk files that VVOL encapsulates. E6i uses protocol endpoints to establish a data path on demand from virtual machines to their respective VVOLs. To view the protocol endpoint presented to a host, in the Host and Cluster tab of the vSphere web client, we click on the target host, then select the Configure tab, and select Protocol Endpoints from the menu. Here, we can see the protocol endpoint, the paths, and the data stores themselves. Now that the VVOL datastore is mounted, we can clone a virtual machine to the VVOL datastore we've just mounted. I'm cloning a Windows 2016 virtual machine from a vmfs datastore to the VVOL datastore. This process will take a few seconds to complete. We can also navigate to the PowerStore UI to see the bandwidth, as this is a regular copy on write operation. A virtual machine can be easily and non-disruptively be migrated from a VMFS to virtual volume via a storage vMotion operation. This will convert virtual disks into separate virtual volumes on the array. As we can see, the cloning operation completed. So now let's power on the VM and check its files. With VMVOL-based virtual machines, there is no file system, but VMware makes the structure appear to be the same as of a conventional virtual machine. What occurs internally is quite different, however. Now, let's take a look at it from the array side. The VVOL architecture not only gives VMware insight to the PowerStore array, but it also gives the PowerStore array into VMware. The granularity provided by virtual volumes gives the PowerStore array the ability to understand the virtual machine objects and its various virtual disks. In our example, as you can see, a VVOL-based virtual machine uses 4 types of VVOLs. Configuration VVOL, usually called config VVOL. This is one VVOL per VM. This is a VM's config VVOL file that stores the file required to build and manage it, such as VMX file, logs, VMDK pointer, etc. Then we have the data VVOL, one or more per virtual machine, as this is actually the data VVOL on the array that corresponds to a virtual disk. Then we have the swap VVOL, which is one per VM. VMware creates swap file for virtual machines of all types when they are powered on and deletes them at power off. Another type is memory VVOL. When a VMware administrator suspends a virtual machine or during snapshot creation, VMware stores its memory state in a memory VVOL. We will see example of this one soon. This virtual machine is configured to run automatic random workload. By navigating to the Virtual Machine tab, we can see useful information about the virtual machine and their storage metrics. As VVOLs are provisioned as fin-provisioned disks, we can see the provision capacity and also the free capacity, compute performance of that virtual machine, storage performance, protection policies, and the different VVOLs. By navigating to the Storage Performance tab, we can see the latency, IOPS, and bandwidth of that specific virtual machine. The integration between PowerStore and VMware VVOLs allows us to create managed snapshots. With VVOLs, when a new snapshot is created, VMware does not create the performance-impacting Delta VMDK files that were traditionally used, but instead, VMware entirely offloads this process to the array. So the array creates the snapshots and VMware just tracks them. This snapshot, called Manage Snapshot. This is what is created when you initiate a snapshot of a VM that is using VVOLs via a VMware interface, such as vSphere Web Client, PowerCLI, VRO, PowerProtect, etc. This process creates array-based snapshot that VMware knows about. By navigating to the PowerStore UI and clicking on the VVOLs tab, we can see the two snapshots at the array level. So when a VMware managed snapshot is taken, VMware actually tells the array to create a snapshot of each data VVOL. So there is a point in time of each and every virtual disk. As you can see, the config VVOL is not snapshotted. There is no real need for that, as the configuration information of the snapshot is actually stored in the config VVOL itself. In addition, you can see the memory VVOL I mentioned before, which stores the memory state of that VM. A major benefit for VVOLs with PowerStore is that snapshots are now PowerStore volume copies, which are globally data-reduced, metadata-based, so their creation, restore, and deletions are instantaneous, and they are not copy and write, so there's no performance impact during creation and deletion. Now, let's clone our virtual machine to the same VVOL data store. When virtual machines are stored on a VVOL container, anytime a virtual machine is cloned onto the same VVOL container, the system will use VAS API clone virtual volume and offload the entire clone operation to the array level. By navigating to the PowerStore UI and clicking on the VVOLs tab, we can see that our VMware clone is actually a clone at the storage array level. This makes the VMware cloning instantaneous and efficient, while these clones are also globally data-reduced and metadata-based. I hope you will find this demo useful, and thank you very much for watching.